Branching is one of the three fundamental control structures in any computing language. Sequence you're already familiar with. That is one instruction following another without any deviation in the path. Branching is the ability of the program to make a decision based upon a condition. So if this condition is met, or if this condition is true, we can cause the logic to go in one direction. And if that condition is false or non-existent, then we can cause the logic to go in another direction. Java supports this in a number of different ways, but let's take a look at how it fundamentally works before we look at the code. We use simple Boolean expressions. That is, things that are going to evaluate to true or false, or to 0 or 1. So if it's raining outside, we will issue the instruction to take an umbrella. Otherwise, or else, take your sunglasses. We will assume that if it's not raining, that it's sunny, and we'll need the sunglasses on the way out the door. Java gives us three tools to build this kind of logic into our program. The simplest one is the if construct. So if, open parentheses, and then the Boolean expression inside of the parentheses. So if raining equals true, the double equal sign is our equality operator. If raining equals true, then the method take umbrella is called. After take umbrella is called, then person leave for work method is called after that. Now it's important to understand that whether it's raining or not, the very next instruction that the compiler finds is what it's going to execute. So if it's raining, then take umbrella will be called and it'll be processed, and then leave for work will be called. If it's not raining, then take umbrella will not be executed, but leave for work will always be executed. So if we use a simple if statement, just as we see it here, if we use that, we must be mindful that the very next instruction will always be executed. When we want to control what happens in our program, whether the expression is evaluated to true or false, we add the else clause to it. So we have our first line just as we had previously. If raining equals true, then the take umbrella method is called. Else, or otherwise, if raining is false, then the take sunglasses method is called. In this case, or in either case, whether it's true or false, again, leave for work will always be processed. There is one further form of the if-else construct, and that's the if-else-if. What this allows us to do is build some complexity into our evaluation. So if raining equals true and windy equals false, then we execute the take umbrella method. Else if, so if one of those two conditions doesn't work out, then we drop down and we check again. If raining and windy are both true, then we take a jacket and take an umbrella. So the clauses, the group of instructions is controlled by the two curly braces there. And so everything within those braces is controlled by that else if statement. Finally, we have another else statement, and that other else statement says everything above this has evaluated to false for whatever the conditions were. Then we assume that it's sunny outside, and we call take sunglasses. Again, either way, leave for work is always going to be executed. The Boolean instructions that you will build into your if statements, and a lot of other constructs that we will see down the road are going to be built using these relational operators. And they should be familiar to you if you've worked in any other language, and even if you just look at them from your algebra background, you'll understand this. The only one that might be a little bit different is the equality operator, and that is the double equal sign. Remember, the single equal sign is the assignment operator. This is also the biggest source of errors for beginning programmers and experienced programmers as well. You will type that in, a statement will execute over and over and over and over because the assignment is true. The assignment was successful, and so it evaluates out to true. So that's the first place to look if you've got errors. The bang and the equal sign is not equal to, and then the less than, equal to, greater than, or equal to. Those you understand as well. You saw in the else if example that we connected the different expressions with logical operators. So we use not the bang operator there. The exclamation point is this converts it to not true. So if it's not true, and if both sides of that, so if it's windy and it's rainy, or evaluates to true if either side, if it's windy or it's rainy, then it would evaluate out to true. So you can see just using simple operators that you can build some pretty complex evaluation statements into your program and then control the flow of your logic based upon the evaluation of those statements. Moving from the concept of branching to coding branching is a really small step. This is a very simple set of constructs, and it's pretty easy to understand. We're going to come back to the class that we started working on in the previous video called SAW. If you remember, it represents it models a number of different types of power saws that are existent in my shop. One of the things we've added now is this this size check called max blade. The maximum circular blade that I have in my shop is 12 inches. So if any data exceeds that, we want to be warned that we are modeling an incorrect size blade. As a matter of fact, that's the first thing that we will do is go and look right here at the set blade size method. We've added a simple if statement here. There's no else clause to this. So if in size, if the parameter in size contains a value that is greater than max blade. So if I try to instantiate an object with a blade of, 15 inches, then an error message is going to pop up. In this case, I've added the additional step of allowing me to correct the input before the object is instantiated, so that I know that all the data in this object is correct. So what we will do to test this is to pass a valid value which will fail this, and if it fails this evaluation, in size will be less than or equal to maximum blade. Then control will shift from here down to the next instruction that is beneath the bottom curly brace, which is simply the assignment statement. If, on the other hand, this evaluates to true, so if true in size is greater than max blade, then the instructions that are inside of the curly braces will be executed. So we'll set this up, and I'm going to create two new saw objects, saw 1, saw 2. Saw number 1 is going to exceed the blade size, so 14, while saw 2 is 10, and that shouldn't generate any error. So let's execute this and see what happens. Okay, and just as we expected, when SAW1 gets instantiated, the accessor function stops that value of 14, says that is out of range, and it asks me for a correct value, and that is the chop saw, so 12-inch. We'll set that to 12, hit enter, and we're good. Notice that no error message was generated by SAW2 because the value of 10 inches is less than the maximum blade width. So that's a simple if statement. We can look at an if-else statement, which allows us to control both sides of the operation. So we're going to go to check cut. Now what this does is evaluate whether or not the cut size or the finished piece size is within the safety zone, or if it's a dangerous cut because the line would exist inside of the danger zone on the saw. And we've determined that that rectangle, the length of the zone, the safe zone around the saw where you don't want your fingers to go, and then the width with the blade being straight down the middle of that width. That's our assumption for this model. So we're going to ask another question. The work width is the value that is shipped in as the parameter to this method. If work width is less than the safe width, so if we're getting the safe width that's set for that particular saw, and it's different for each of the saws, divided by 2 because we're running it right down the middle. If that's true, so if it is inside of there, we're going to issue this warning message so that the operator picks up a gripper or a push stick or something. If this evaluates to false, we don't want it to just drop out. We also want to remind the operator to be careful on the cut instead of just ignoring it. So here's a dangerous cut. We're issuing a direct instruction. You must use a push stick. On the other hand, if it's outside of that, so let's say it's, the cut is 6-8 inches wide, whatever, then in that case, we just recommend that they be careful. That they use a push stick anyway, just to err on the side of caution. So if we're going to test this, we will go down and we are going to uncomment this. And actually, we're going to uncomment all this. Okay, and let's correct this so we don't stop here. Set that to 12. Okay, and so on saw 1, cut 1, the cut is 3 3/4 inches, and it's made on saw C. So the cut width, or the safety zone width, is 18 by 4. So when we divide that by 2, 3 3/4 is outside of the 2. So we get that this is a safe cut. Your fingers are not going to come within the danger zone pushing this piece through. On the other hand, we're going to make a 1-inch strip that we're going to push through the saw. And when we make cut 2 down here, we test that against saw 2, and the saw 2 width is 14 in length by 2 inches wide, so very small. So because 2 divided by 2 is going to give us 1, we have a 1-inch cut. That is going to fire the danger here, and we're going to get the dangerous cut message just like we see there. So if else, a modification of the simple if statement. If this is true, perform the instructions in this part of the body. Else, instead of just dropping through to another instruction, we actually control what goes on here. So if it evaluates to true, do this. If it evaluates to false, do this. So a simple if else. A modification then to the if else statement is the if else if, else if, else if, else if, as deep as you want to make it. One of the things that we verify is that the user has given us a correct saw type. So the codes that are utilized in the shop are C, M, and T. These are the types of saws that are in my shop. And so if the user passes us a lowercase c or an uppercase c, same thing with the M, same thing with the T, if either of these is true, then I will assign that parameter to saw type, to that member variable. If this evaluates to false, it could be because this is M. So else if this is true. This evaluates to false, else if this is true. If any one of these evaluates to true, then the assignment will be made. The parameter in type will be assigned to saw type. On the other hand, if each one of these evaluates to false, if they fall through, then finally this last else clause, the body of these instructions, is going to fire. So we send an invalid saw type warning out to the screen, and I assign blank to the saw type, which I can use later on to indicate that I don't know what cut to make or however I want to handle that. So we'll come back in here and we'll make a saw3. So let's instantiate an object called saw3. I'm going to pass it the X this time, and let's see what happens. And as we expected, it evaluated and gave us the error message. So it evaluated this false. So it's not equal to X, not equal to uppercase X. I'm sorry, C or C. X is not equal M, X does not equal T, so fail, fail, fail. Finally, the else clause fires. So we have the ability to test any number of different types of circumstances within a single structure. The downside of this, of course, is that it takes a lot of code to evaluate something like this. It could be tempting to use the if, else if, else if, else if, and on and on and on structure to build some complexity in the flow control of your program. But Java offers us an alternative in the switch construct that allows us to really simplify the logic that we use to control flow. It works with certain data types: integers, short integers, bytes, and characters. But apart from that quote-unquote limitation, it's really a useful construct, and it works this way. The switch keyword is then followed by the expression that you're going to evaluate. So let's say menu choice. Okay, so choice, whatever the user has entered for their choice. Then we can run down a list of cases that are followed by a constant. This will make more sense. Well, let's just turn the page. This makes more sense when we look at this. So the user has entered a variable menu choice, and it's going to be a single character. And then we can evaluate every possible menu choice that they gave us. So if they entered a lowercase s or an uppercase s, then the save method is executed. If they entered O or uppercase O, the open. If they did not enter either one of those two choices, the default case fires, and we simply output an error message that says you've chosen an invalid choice. An important thing to remember when using the switch is that the break statement there you see after save and after open, that break essentially controls the entire structure. So after save is called, the break is encountered, and that drops us completely out of the switch construct. So whatever the instruction is that follows the switch construct, that's where it'll drop down to. If you leave the break out, and one of these days you'll leave the break out, it will execute object.save, and then it will go down to the case O and then so on and so on and so on down the list. So if you want to execute out of, if you want to move your logic outside of the switch, you've got to remember to put that break in there. As you saw in the PowerPoint, the switch construct simplifies that if, else if, else if, else if, allowing us to stack up a number of different types of evaluations. So again, same parameter, in type, in type. The case is lowercase t, uppercase t. Now, one of the nice features of the switch is that I can stack all these up, since essentially they do the same thing. So if any one of these is true, if the case evaluates to true, then I do the assignment statement. You see how much simpler this is than the if, else if, else if, else if. So if this type of logic fits this construct, this is preferable over the if, else if, else if. If we run this, we should receive the same outcome, and we do. Invalid saw type X. Now if we go back in, we can test that to see if it actually works, and we'll make this an uppercase C, and we'll run it again, and no error message. So we have cleared through. So we know for sure this is the problem. That's the switch construct, a substitute for the if, else if, else.